Question number 10, Edexcel C1 2014. We've got a curve, this one. I'm going to undo that differentiation to find f of x. And we can find c because we're given a point that the line goes through. And find the equation of the normal to the curve. So a bit of differentiation there, and then use that to find the gradient of the tangent, then the gradient normal. So we get 10 marks for this. Nice reward for the work that we're going to do there. So what do we do to get from f to f dash? We differentiated it. So to get back from here to here, we undo the differentiation. So f of x is equal to undo the differentiation, which means we integrate 3x squared over 8. Take away 10x, so minus a half, plus 1. And when we integrate, we add 1 to the power and divide by new power. So 3 over 8x cubed divided by 3. Take away 10 times, add 1 to this power, we've got x to the half divided by a half. Add 1, this is really add 1 times x to the power of 0. So we're going to add 1 to the power of 0. We get 1. And we divide by 1. I'm not writing that 1 in, I'm not going to divide by 1 either. And then we add c. So simplifying this, we've got f of x equals the 3 and the 3 cancel, I've got x cubed over 8. The half divided by a half is the same as doubling, so 20x half plus an x plus a c. But this point on our curve means that we can substitute f of 4 in for 25, and we can sub x is equal to 4 in. So we've got a term there, term there, term there that we can evaluate, and that will give us c. So 4 cubed is 64 divided by 8. 4 rooted is 2 plus 4 plus c. So 64 divided by 8 is 8. So 25 add 40 is 65. Take away 8 and 4 is 53. Which means that f of x is equal to, let's copy this bit out, x cubed over 8, take away 20x rooted, plus an x, plus c, but we can sub the value of c in now, so plus 53. Done. 5 marks. Find the equation of the normal to the curve at the point 425. So we know that the gradient of the tangent, so this is part B up here, gradient tangent is equal to f dash of 4, and that's at 4,25. And this is equal to 3/8 of 4 squared. So look, this is the gradient equation. We want to find the gradient when x equals 4, and that will be the same as the gradient of the tangent of the curve at that point. The gradient of the tangent of the curve means put 4 into here, so I'm going to put 4 into each term, which involves an x there. Take away 10 divided by root 4 plus 1, and that's equals, so 4 squared is 16 divided by 8 is 2, times 3 is 6, 10 divided by 2 is 5, add the 1, and that's equal to 2. And the gradient of the normal is equal to minus 1 over gradient of tangent is equal to minus 1 over 2. And we want the equation of the normal to the curve, so we're going to use y, take away y1, but our y1 is 25, is equal to gradient m, in this case the normal gradient, because we want the gradient, the equation of the normal, bracket x, take away x1, x1 is 4, and we need to, so we've got all but that final mark really now, because we are given a format that they want the answer in. So we've got y minus y1 equals m bracket x minus x1. The easiest way to turn that format into this one is double this side to give 2y minus 50. And we can multiply this bracket out at the same time. So minus 1 times x, minus 1 times minus 4. And then this says get everything over on the same side. Integers, look, we've got integers. and equals 0 on the other side. So I'm going to add the x and take away the 4, and so 2y plus x, take away 54, equals 0.